See, the term pomology refers to the study of fruit crops. It mainly focuses on the development, cultivation and physiological studies of fruit trees. The goals of fruit tree improvement include enhancement of fruit quality, regulation of production periods and reduction of production cost. Special operations in fruit crop includes planting, cropping system, training and pruning are some of the critical operations which comes under the special operations for fruit crops. Planting. Here selection of the plants from the nursery is very important. Generally the plants are purchased from the nursery well in advance. The grower should visit the nursery and select the plants. Plants are selected on the basis of specific characters of the plants. One is branching. The main branches on the young plants become leaders on a grown up tree. These branches arise on a plant at an angle which is called crotch. This crotch should neither be wide nor narrow, but it should be medium, that is 40 to 50 degree. If the crotch is wider, splitting or breaking of limbs will occur because of heavy crop load. If it is narrow, say less than 30 degree, it forms weak framework. So, plants having medium crotches are the best suited. The branches on the trunk should not be opposite or in a whorl, but alternate with at least 15 centimeter spacing. The growth of the plant is also very important in the nursery. The plant should be uniform in growth and is determined by the uniform length of internodes. For immediate planting, plants in active growth should not be selected because they may wilt during transit or die on planting. Deciduous fruit plants should be planted when dormancy is about to terminate. They put forth new growth quickly and establish early. Then regarding the age of the plants, growers generally prefer older plants believing that these plants come to bearing early. This is not true. Younger plants make up in a few years and become equally vigorous and outgrow older plants. So, no benefit of selecting older plants. Choosing young plants have many advantages like cheaper in cost, easier to transport and they withstand transplanting shock, easier to transplant. Pest and diseases. The plant should be free from pest and diseases like scale insects, mealybugs, aphids, nematodes etc. in the nursery and diseases like canker and viral diseases. How to lift and pack the nursery plants. Before lifting the plants from the nursery, the plants are thoroughly irrigated one day in advance for easy lifting of the plants without damage to the root system. Then the plants are lifted carefully along with a ball of earth attached to the root system. The roots are wrapped in straw or grass or covered with a gunny cloth and placed in a basket or a wooden crate for packing. Depending on the size of the basket or crate, 6 to 7 plants are kept for each basket. 4 to 5 long bamboo splinter or wooden pegs are forked into the sides of the basket and tied at the top. In between the plants and at the top of the basket after filling, plants are covered with straw so as to avoid falling during transit. Season of planting. The distribution of rainfall in the tropics and subtropics and the break of spring growth in temperate zone determine the season of planting. In tropical climate, most trees are planted between July and December and few in January also. In general, planting is done during the monsoon in moderate rainfall areas and at the close of monsoon in heavy rainfall areas. Planting should be done on cloudy days and preferably in the afternoon rather than in the morning. Regarding the planting method, planting board should be used at the time of setting the plants so that they are in a perfect line. These plants should be set at the soil at the same level as it was in the nursery. The bud or the graft joint should not be covered with the soil. Plants should be irrigated once copiously to get the soil particles to closely adhere to the roots and also to drive away the air around the roots completely. The plant should be staked with a straight bamboo piece or other twig. Graft bandage should be removed if not already done. Any buds on the rootstock should be rubbed off or ripped off. Healing in. See, if the plants after transport are not directly planted in the field, they may be kept in shade in a slanting position along with side of a trench, moistening the ball of earth. They may be left in this position till active growth commences, by which time they should be planted in the field. This process is known as healing in. Now we will see the cropping system for food crops. Systems of cropping are the way in which different crops are grown. Sometimes a number of crops are grown together or they are grown separately at short interval at the same field. The cropping system may be broadly divided into sole cropping, monocropping and mixed intensive cropping. The cropping system, one is the sole cropping we will see. Here only one crop or a particular variety, one single variety alone is grown as a pure stand at normal density. Then monocropping, here this system is the repetitive growing of the same crop on the same land for over a period of time. Then mixed cropping is the process of growing two or more crops together in the same piece of land. This system of cropping is generally followed in areas where climatic hazards such as flood, drought, frost etc. are frequent and common. Besides, to enhance the income, mixed cropping is good. The principles of mixed cropping we should understand. The most important point is the selection of crops. Crops which compete with each other should not be chosen. Therefore, some of the important points should be taken into consideration while selecting the crops. One is legumes should be sown with non-legumes crops. Example, beans with chili. Then tall growing crops with short growing crops can be combined. For example, brinjal is a tall crop, it can be combined with onion which is a small crop. Deep rooted fruit crops with shallow rooted crops. Say for example, in coconut garden we can grow tree crops like nutmeg which is a deep rooted one. Then pushy crop with erect growing crops. Then crops being attacked by similar insects. For example, cashew and mango should not be planted because they are affected by same pest. Advantage of mixed cropping is here all the crops do not fall under adverse climatic conditions. Example, frost kills only legumes, flood kills only dicots and drought kills only monocots or shallow rooted crop. Then the epidemic attack of any pest, insect or disease kills only one crop without affecting the rest of the crops. Then farmers grow different crops which balance their daily need or demand for the cereals, pulses or the oil seeds. Mixed cropping checks soil erosion, weed control etc. It improves or maintains the soil fertility. Then last system is the intensive cropping. Here intensive cropping is the process of growing a number of crops on the same piece of land during the given period of time. In other words, when the area is limited and the number of crops to be grown is increased with a definite period of time, this cropping method is termed as intensive cropping. Sometimes it is also referred as multi-tier system of cropping in horticulture. The main objective is to increase the income per unit area within a specific period of time. Some of the prerequisites for intensive cropping if you see, one is the high yielding and short duration crop varieties are mixed. Better and efficient plant protection measures can be given and excellent soil conditions can be obtained. Methods of intensive cropping, if you see multiple cropping, here it is defined as a cropping system in which two or more crops are grown in succession within a year. Second one is the relay cropping. Here it is analog in a relay race where a crop hands over a land to the next crop in quick succession without much gap. Best examples of relay cropping are cluster bean, early potato and coriander cropping system. Then overlapping system of cropping. In this system of cropping, the succeeding crop is sown in the standing preceding crop. Thus, in this system, before harvesting one crop, the seeds of the next crop are sown. Example, potato and coriander. The next is training. Let us define what is training. The physical techniques that control the shape, size and direction of plant growth are known as training. And why it involves or it aims many objectives: to improve the appearance and usefulness of plant or the tree through providing different shapes and securing balanced distribution, to ease cultural practices including intercultivation, plant protection and harvesting, to improve the performance like planting at an angle of 45 degree and horizontal orientation of branches make them fruiting better. Some of the training methods we will see. This method of training a particular plant is determined by the nature of plant, climate, purpose of growing, planting method, mechanization, etc. And therefore, intelligent choice is necessary. Training in herbaceous annuals and biennials. Here staking or supporting a vine like plant is required. Training on pergola or trellis of vine type fruit plants or even indeterminate type of tomato. The nipping of apices or the tip for encouraging lateral growth to give bushy appearance or fulsome appearance in pot plants like aster, marigold, chrysanthemum. De-shooting or removal of lateral buds for making single stem for large flowers as in chrysanthemum or dahlia. Then staking with the bamboo sticks and tying together various shoots in potted chrysanthemum, etc. But in the case of woody perennials which are widely spaced and remain on a place for long duration, trainings are required for developing strong frame for sustainable production of quality produce and also for ornamental beauty in different shapes, that is topiary work. The different systems followed are open center system, it is also known as vase shaped. Then central leader system, it is again called closed center system. Then modified leader system, cordon system, training on pergola, training in different shapes, etc. What is meant by pruning? Pruning actually refers to removal of plant part like bud, shoot, root, etc. to strike a balance between vegetative growth and production. This may also done to adjust fruit load on the trees. Pruning aims to maintain the growth and vigor of the trees and to have a balance between the vegetative vigor and fruitfulness so as to be conducive for production of optimum crop of best quality. To shape the tree to make the best use of space between trees while allowing the necessary access. To regulate the size and quality of fruits by way of proper distribution of the fruiting area. To regulate succession of crop and to have the crop where it can be managed easily and cheaply. To spread the trees of economic orchard management. To remove the dead, diseased and overaged woods. For effective spraying of pesticides to the crop. To minimize biennial bearing and consequent risk of dieback. To get maximum plagiotropic shoots or stem, that is the side laterals. Establishment of transplant where leaves, shoots are pruned to strike a balance between roots and shoots so that plant lose less water against restricted root system lost during lifting of plants. Elimination of non-productive vegetative growth like water shoots, suckers, dead and diseased wood, etc. If you look into the type of pruning, basically there are three types of pruning with different purposes. Frame pruning. Here it is done to provide shape and form to a plant in its formative years, that is the initial years, so that the tree develops strong framework and a shape for ease of operation. Second one is the maintenance pruning. Here it is to maintain status in production level and for uniform performance of this pruning is done. Then renewal pruning, here it is done in old trees like mangoes which shows decline. In this case, severe pruning is required to restore its vigor and quality. Then top working, it is a technique or method of rejuvenation wherein The objective is to upgrade seedling plantations of inferior varieties with superior commercial cultivars or hybrids suitable for domestic or export market or desired variety of the grower. The technique involves grafting with procured scions of desired variety on shoots emerged on pruned branches by adopting softwood grafting during monsoon months. Next, we will see the principles of canopy management. Canopy in a tree or fruit tree refers to its physical composition comprising of stem, branches, shoots and leaves. The canopy density is determined by the number and size of leaves, architecture of the stem, branches and shoots. Canopy management of the fruit deals with the development and maintenance of their structure in relation to the size and shape of the maximum productivity and quality. The concept of canopy management, we should understand the basic concept in canopy management of a perennial fruit tree is to make best use of the land, the climatic factors for an increased productivity in a three-dimensional approach. Tree vigor, light, temperature, humidity play a vital role in the production and quality of the fruits. Major objective is to achieve maximum productivity in a shortest period without adversely affecting the tree health and bearing of the orchard. The natural tree canopy of the fruit tree varies greatly from species to species and cultivar to cultivar. The size, shape and volume of canopy are affected by climate, planting density, rootstock, method of propagation, training, pruning, regularity of bearing, soil type, nutrition, irrigation, intercrop, growth regulators used, disease, pest and environmental pollutions, etc. The basic principles in canopy management are maximum utilization of the light, avoidance of build-up of microclimate congenial for the diseases and pests, convenience in varying out cultural operations, maximizing the productivity and quality, economy in obtaining the required canopy architecture. Now, we will see the principles of growth regulators, then how the growth regulators are used in fruit production. Say growth mainly refers to the quantitative increase in plant body such as increase in length of stem, root, number of leaves, fresh weight, dry weight, etc. Growth and development of the plant body are controlled by two sets of internal factors, namely nutritional and hormonal. Nutritional factors supply the plant necessary mineral ions and organic substances such as proteins, carbohydrates and others. These constitute the raw materials required for growth. However, utilization of these substances for proper development of a plant is controlled by certain chemical messengers called plant growth substances or plant growth regulators, which in minute amounts increase or decrease or modifies the physiological processes in plants. Plant growth regulators or plant growth regulators are organic compounds other than nutrients which modify or regulate the physiological processes in an appreciable measure in the plants when used in small concentration. They are readily absorbed and these chemicals move rapidly through the tissues when applied in different parts of the plant. Plant hormones are also known as phytohormones are also regulators but produced by the plants in low concentration, and these hormones move from site of production to the site of action. Therefore, the difference between plant regulator and plant hormone is in that the former one is a synthetic one while the plant hormone is a natural product from the plant source. Now, we will see what are all the different growth regulators we have. Mainly we have 5 groups: auxin, gibberellin, cytokinin, ethylene and abscisic acid. These auxin, gibberellin, cytokinins are put together we call growth promoters, whereas ethylene and abscisic acids are called growth inhibitors. Then there is another group called growth retardants, which are normally the chemicals which have a common physiological effect on reducing the stem growth by inhibiting cell division. Some of the role of growth regulators in fruit crops we will see. One is propagation of plants. The most common use of plant regulators in horticulture is to induce rooting in stem cuttings or in air and soil layers. Auxins like IBA, IAA, NAA are the most commonly used root promoters in cuttings, layers, grafting and budding. Aqueous concentrations ranging from 100 to 500 ppm are used for long dip method of treatment of cuttings for 12 to 24 hours and high concentrations of 10,000 to 20,000 ppm for quick dip method for a few seconds. Application in the form of dust as a talc preparation or in the form of a paste in lanolin are also used. Control of flowering can be also done by use of growth regulators. In the case of pineapple, pouring of 50 ml of solution containing 0.25 to 0.5 milligram of the chemical NAA in the central core of plants induces flowering. Psychosel, alar at 5000 ppm and ethyl at 100 to 200 ppm induce flowering in mango during an off year. In Jasminum grandiflorum, the flowering period is extended by the application of psychosel at 500 ppm. Plant growth regulators also increase the fruit setting in fruit crops, for which various growth regulators like IAA, IBA, IPA, NAA, 2,4-D, 2,4,5-T and GA are used, which increases the fruit set in many fruit crops. The optimum concentration for this purpose is 10 to 20 ppm of auxin and 10 to 100 ppm of GA in different crops. Spraying the flower cluster thoroughly 4 to 6 days after full bloom with 100 ppm of GA increases the fruit set in grapes. Next use is to prevent the fruit drop. Losses resulting from pre-harvest fruit drop of fruits have long been considered as a serious problem. Pre-harvest fruit drop in citrus is controlled by application of 2,4-D at a concentration of 20 ppm and 10 to 15 ppm of NAA or 2,4,5-T at 15 to 30 ppm at P stage and marble stage and 2,4-D at 20 ppm and 2,4,5-T at 10 to 15 ppm in mandarins. At 10 ppm and NA at 20 ppm have effectively prevented fruit drop in mango, apples and pear crops. Then induction of parthenocarpy is also possible through use of growth regulators. Parthenocarpic fruits set could be induced in fruits like guava, strawberry, citrus, watermelon, etc. See the auxin group like IAA, IBA, NAA, NOA, NAD, 2,4-D, IPA and GA are effective in different plants. Application of GA at 100 ppm induce complete seedlessness in grape varieties. Fruit ripening in many crops. Plant growth regulators are employed to hasten or delay fruit ripening. For example, 2,4,5-T at concentration 25 to 100 ppm hasten the ripening in plums and peaches. In the case of banana, ethyl treatment at 2500 ppm induces ripening within 24 hours. To improve the fruit size and quality, growth regulators are extensively used. Spraying of GA at 40 ppm at bud and flower stage increases the size and length of berries in grapes. Now, we will see the preparation of growth regulators. So, solution form. To prepare the solution form, an alcoholic solution of any plant growth regulator is required, for which dissolve 1 gram of growth regulator in 50 ml of ethyl alcohol or methyl alcohol or methylated spirit, then dilute this with an equal volume of water to make 100 ml of the solution containing 10,000 ppm of growth regulator. This will act as a stock solution for further dilution with distilled water or deionized water, and such things should be stored in well stopped bottles in a refrigerator, and the solutions retain their activity indefinitely if stored properly. Dust form. To prepare a dust form containing 10,000 ppm of growth regulator, we can dissolve 1 gram of the regulator in 40 ml of methylated spirit of 90% alcohol. Stir this into 100 gram of pharmaceutical talc to form a smooth paste. This should be done in a dark room away from strong light. Stir the paste while it is drying until it becomes a fine powder. This prepared dust remains active for 6 months or more if stored in a closed opaque container in a refrigerator. From this stock, before using, dilute the growth regulator by mixing the stock with required quantity of talc powder. Third method is lanolin paste. To make paste containing 500 ppm of growth regulator, melt 200 gram of lanolin and thoroughly stir into the molten lanolin 1 gram of required growth regulator. This prepared paste will keep indefinitely if stored in a well stopped opaque glass vessel in a refrigerator. To sum up, pomology is the study of fruit crops. It mainly focuses on the development, cultivation and physiological studies of fruit trees. The goals of fruit tree improvement include enhancement of fruit quality, regulation of production period and reduction of production cost. Critical operations in establishment and maintenance of fruit crops include planting, cropping system, training, pruning. Canopy in a fruit tree refers to its physical composition comprising of stem, branches, shoots and leaves. Canopy management of the fruit tree deals with the development and maintenance of the trees in relation to size, shape for maximum productivity and quality. Regulation of growth, flowering, fruit bearing is important in fruit crop production system for maximum productivity. Plant growth regulator or plant regulators are the organic compounds other than nutrients which modify, regulate physiology process in an appreciable manner in the plants when used in small concentrations.